All right, welcome America, welcome Justin Bieber. We are recording live. Thank you for the reminder. We are not welcoming Justin Bieber anymore because he never showed up to my class. We are now welcoming Taylor Swift daily. Thank you. I don't know, I just get in the habit because I made, how many of our videos last year? I said it every single day. So Tay, right at you, right at you. Okay, but I love Justin Bieber. Y'all don't love Justin Bieber? Andrew, please. We're trying to record. Let's talk about that after. Okay, so on the quiz review warm-up, I just want to do one problem, and that is on what interval is f of x greater than 0? Where are the y values on this graph greater than 0, which is above the x-axis? So from, and I think I like the highlighter for this, right? From here to here, right? From here to here, the graph is above the x-axis. And then also from here to here, the graph is above the x-axis. Now, how do we say that? So now we want the y values that are greater than 0, not greater than or equal to 0. So from -6 to -2, is that right? -6 to -2. And we also have from 0 to 8. Now we're not including the -6, we're not including the -2, we're not including the 0, and we're also not including the 8. The reason we're not including the 8 is because we don't know what happens after that 8, at 8.1. The graph is stopped. So we don't know what's happening. We don't know at what interval, yeah. You know what? I'm thinking twice about that 8. Because the value for the y value at 8 is greater than 0. So let's leave it, but technically we can include that value because at that point it is on the graph and that value is above 0. Yeah? Let's include it.
I wrote it down.
We're not doing increasing, decreasing. We don't have to worry about whether if we were asked if the graph was increasing here, we'd have to stop at 8 and not include the 8 because we don't know what's happening after the 8. We don't know if the graph is increasing or decreasing at that point. However, we do know that point is on the graph and it does have a y value that is greater than 0. So let's include it. Moving on. Any questions? All right. Can I close this? Now we are moving to this worksheet. I think it's in the packet somewhere. The next page or the next 2 pages somewhere. So I think I'd like to record the first problem because we're still, piecewise functions are hard. They're always difficult to graph. So I'd like to go ahead and just do another one of those. So we've got a break in our graph at -2. So I'm going to, with my highlighter, just lightly put in a reminder for myself there that I'm going to have the first graph, y equals -3/2 x plus 1, for x values less than -2. And then for the second equation, y equals x squared plus 4, I'm going to have that graph for x values greater than or equal to -2. So that's why I put that there. And usually if I'm going to draw something that's not included in my graph after I draw the graph, then I would want to erase it. All right, so let's start. Y equals 3/2 x plus 1. How would we graph that? As a regular equation from Algebra 1, we look at the slope as -3/2, and we have a y-intercept is where we start at 1. So I'm going to put a little dot there. I'm going to make them a little bit larger because when I was watching my video the other night, Emma was right. I couldn't even see the dots on the screen here, so you guys have to be able to see them. So from there, slope is -3/2. So I'm going to go over 2 up 1, 2, 3. Over 2 up 1. Oops. 2. And over 2. something like that. Okay, now, I'm just putting dots here because I just want to kind of draw the line here. -3/2 x plus 1, but I only need that graph up to, but not including on this line, because we need that graph for x values less than -2. So there's going to be an open circle here at x is less, or x equals -2. Any questions, comments, anything? You guys are usually really good about correcting my mistakes, giving me guidance, reminding me about no more Justin Bieber. Kelvin giving a call out to Justin Bieber every day didn't work. Let's try something else. Got it. All right, next one, y equals x squared plus 4. So y equals x squared. Let's kind of quickly review what that looks like with an xy chart. If you plug in 0, you're going to get 0. You plug in 1, you're going to get 1, because 1 squared is 1. If I plug in -1, that's the quantity -1 squared, so it's -1 times -1. It's a positive 1. So those are really the 3 points that you're going to use from your parent function. And we take that whole parent function, y equals x squared, and we're shifting it up 4, which is what we're learning today, transformations. Shifting the whole thing up 4. So I'm just going to take those 3 points, and I'm going to move those 3 points up 4. So start here, there's my 0, 0. I'm going to go 1, 2, 3, 4. There, there, and there. And that's where I'm shifting them up. So really, instead of graphing 1, 1, and then up 4, what I usually do is from my new 0, 0, I just go over 1, up 1, over left 1, up 1. That's usually what I'm thinking in my head when I graph it. All right, so now we need the rest of the graph, and we need this graph for x values greater than or equal to -2. So the next point, if I plug in 2, 2 squared is 4. If I plug in -2, I still get a positive 4. This is an even function. Okay, so from the 0, 0, over 1, up 1. Now you can't see it on here. I should make those a little bit bigger. And then over 2, up 1, 2, 3, 4. Ooh. This board is so sensitive. And then left 2, 1, 2, 3, 4. We're going to include that point because we need the x values greater than or equal to -2. So boom. That looks good. I'm checking my work on paper and we're good. Any questions on that? I know it's been a bit since we've graphed a quadratic. Unit 4, I think, in Algebra 2. So it's been a while. Any questions? Going once. Going twice. I still see eyes like, yeah.
So when you put the new 0, 0 on the line intercept at 4, is it just because in the equation the 4 is the line intercept?
No, it's because the well, yes. We're really going to do this in class today, but what this means is if you, for example, if I let's say I put a 0 in for x, okay? In the parent function, you just square the 0, and that's just 0, okay? Here, you have the 0, and then you're adding 4 to it. So you're taking that value and you're moving it up 4, from 0 to 4. If I plugged in a 1, right, it'd be 1 squared, it'd be 1, and then plus 4 would be 5. So you're adding 4 to the y value. So that plus 4 is being added to the y value. So what happens is the whole graph, wherever it's at, it might have a horizontal shift first, okay, and we're going to do that again today as well. But if you have a plus 4 or a minus 2 or whatever at the end, that's a vertical shift. Plus 4 means up 4, minus 2 at the end means down 2. So, same for lines. This original parent function, -3/2 x, without the plus 1 at the end, goes through 0, 0. Or it goes this way, right? 0, 0. And then the plus 1 at the end takes the whole line, moves it up 1. Yes?
Are you supposed to like do the 1, 3, 5 thing on the curve? Yeah, that's what I was going
What's the 1, 3, 5 thing?
Like in Miss Smith's class, we would just go like over one, up one, over one, up.
That's what I just did.
Yeah.
Yeah, that's what I just did. So from here, I don't know what you mean by 1, 3, 5, but from here, from this point, this is my original 0, 0. This is my original 1, 1. This is my original negative 1, 1.
Yeah, like
And I just took those 3 points and moved them up
in
4.
Miss Smith's class, we would just do over one, up 3, and then over 1, up 5.
Okay, yeah, sure, that works.
So what do you
Yeah.
do if it's like 2x to the power of 2 plus 4? Like how would you come in?
Okay, that's in the lesson today, so we'll go over it. All right, so that is transformations, which we're gonna do right now. Maybe we'll record.
Is that the H value?
Thanks, Tay-Tay. What?
Is that the H value?
Peace out. Now you can ask me whatever you want about Justin Bieber. Is that next?
No. Oh, no.